Hello everyone, in this video I'm going to be discussing all the different types of amines and amides. So if you haven't seen how to classify carbons, I highly recommend doing that because what's going to happen is the nitrogen is going to take place of that carbon. So I always said in my videos, the yellow carbon, this like the carbon that I'm focusing on, the central carbon or whatever. Well, this time the nitrogen is going to take the stage and you're going to see how many things are attached to that nitrogen. So in this first example, I'm going to be doing amines. So in the first example, you see one nitrogen in pink connected to a carbon in purple. So since that nitrogen is connected to only one carbon, that's going to make it a primary amine. And again, you can see it as like an NH2. And again, it's only connected to one carbon. So you can put an R group, but technically, I mean, it can be a long chain of carbons, right? But the point is that the nitrogen itself is only connected to one carbon. Okay, in the second example, you see the pink nitrogen again is connected to two purple carbons. So then it's going to be a secondary amine. And I tried to, on the right, show you like a more simplified version, but again, those R groups can be longer. It's just that the nitrogen itself is only going to be attached to two different carbons. Okay. And then the last example, you see the nitrogen attached to three carbons, and that's what you're going to have, a tertiary amine. Because, again, since the nitrogen is attached to three carbons, it itself is going to be a tertiary amine. Now, what is the difference between this and an amide? Well, with an amide, what you're going to see is the same key factor, how many carbons that nitrogen is attached to, but it itself is going to be attached to a carbonyl group. So in other words, the difference between an amide and an amide is the carbonyl. And for those of you who are saying, what is a carbonyl? A carbonyl is a carbon double bonded to an oxygen. So I have it in pink, the C double bonded to the oxygen, but it's also bonded to the nitrogen. That itself makes an amide. The C double bond to the oxygen, single bond to the nitrogen. That group is an amide. Okay, but how does it function? It functions kind of in the same way of the amine in terms of how to classify it. So again, in the first example, the nitrogen is only attached to that one carbonyl, that one carbon. So it's going to be a primary amide. And the second one, of course, you're going to have the carbonyl, but it can also be attached to another carbon. That's going to be a secondary amide. So regardless of, I just want to make the emphasis that the functional group amide is the C double bonded to an oxygen with a nitrogen. Now, it being bonded to other carbons is what's going to make it like it being bonded to another carbon, the one like I have in purple, is secondary. If it's bonded to even another carbon, like you're going to see at the bottom, again, that's going to be a tertiary amide, but it's always going to have that carbonyl group. So the carbonyl and the nitrogen is what makes an amide. And that is the difference between an amine and amide. With an amine, you don't have any carbonyl. You just have, for example, the NH2 or the NH or just the N with the three different bonds to the different carbons, which will be the tertiary amine. With the amide, on the other hand, it's going to be the carbonyl N to maybe another carbon if it's a secondary, or to two other carbons if it's a tertiary, or just the carbonyl N for the primary amide. Again, if you enjoyed this video, again, it takes time to create this content, so please follow, like, share, and thanks again for watching.